Okay, so we ended the last video with ice melting, and then I had you go ahead and finish sorting out the physical and chemical changes. So let's go through, and I want you to check and see if you were right on yours, and if you were, excellent. If you weren't, you can pause the video and go change yours up, okay? So all of us should have the right things in the right spot whenever we turn this in. So let's look at baking a cake. So if we bake a cake, can you turn it back into a batter? No. Once that cake is baked, gas is being released, it gets all fluffy, things happen, and we can't change that back into a cake batter. So baking a cake would be a chemical change. So we're going to scroll down here. Might take just a minute. Come on. There we go. I'm going to drop it over here. Okay. Next, we have digesting food. So everything that we eat or drink, it goes in our mouths, we chew it up, we swallow, it goes in our belly, and then our bodies digest it and change that food into energy. Well, once we eat something and digest it, can we turn that back into food easily? No. So that is a chemical change. It's not reversible. Once we eat something, we can't turn it back in, so we eat a cake. We can't turn it back into cake once we eat it. Okay? Fireworks. So if you have a firework and it goes up into the sky and blows up, can you get all those pieces and particles back together, back into the firework, same as before? No, you can't, because a lot of things happen in a fireworks. So looking at Cool Guys Love Your Phones, we've got light being released, we have heat being released, there's gases being released, all kinds of stuff's happening in fireworks. So that is a chemical change. So we'll come drop this one by chemical change. Put it next to the cake. Okay, lighting a match. What do you think? Is it reversible, not reversible? Is there anything with Cool Guys Love Their Phones on there? There is. So kind of like with the fireworks, light's being released and heat's being released, and there's gases with the smoke. That is a chemical change. So we'll grab this one and move it down here to chemical change. There we go. Next, we've got mowing the lawn. So if we mow the lawn, are we changing those pieces of grass into something new? No, we're just cutting them, right? We're making them shorter, but they're still grass, right? So if we don't have anything changing into a new substance, we have a physical change. So we'll drag this one down, and this is going to be a physical change. And next we have glass breaking. If we broke a window, could we put that back together? We could technically put it back together, because did it make a new substance? No, it's still glass. It's in a bunch of pieces. We could put them back together like a puzzle. It might not look exactly the same, so have a bunch of cracks in it, but it's still glass. So glass breaking is a physical change. Okay. Next, we've got roasting a marshmallow. So if we roast a marshmallow over a campfire, darn these lights, goodness. So if we roast a marshmallow over a campfire, it changes colors, right? It turns dark brown, or if it, it might catch fire. Sometimes my children like to make theirs black. Ugh, it's kind of gross. But once that happens, can we turn it back into a marshmallow that hasn't been cooked? Nope, because Cool Guys Love Their Phones, new things are happening, we've got gases being released, there's color changes, we cannot change that marshmallow back, so that is a chemical change. So we're going to drag that down here, down to the chemical change. There we go. So roasting a marshmallow is a chemical change. Next, we've got lemonade. So to make lemonade, we would squeeze the juice out of a lemon, put it in water, put some sugar in there, and mix it up. So could we easily separate these things out? Did it make a new substance? Not really. All we did was make a mixture. We mixed three things together: water, lemon juice, and sugar, but we didn't really make anything new. I mean, you can separate those things out. You could boil the water, and the sugar would be in the bottom of the pan, and the lemon juice didn't really turn into anything else. We just mixed it with water. So lemonade is going to be a physical change. There we go. Next, we've got rusty nails. So rusty nails. Have you ever seen rust before? It's kind of red and flaky, but what it's doing, the oxygen and water that just from sitting outside, it actually chemically changes the metal that it's turning into rust, and that is a chemical change. We can't get that back. New things are formed. That rust is not metal anymore. So this is a chemical change. So we'll drag this one down here. There we go. Next, we've got slicing bread. So is something new being formed when we slice bread? No, nothing new is being formed. It's still bread. We just cut it into a smaller piece. So is that a physical or a chemical change? That's going to be a physical change. So we'll drag that one over here because it's still bread. Now, what if we toasted those slices of bread? If we put them in the toaster, what happens to the bread? It starts cooking, right? Once it gets crispy on the edges and starts turning into toast, can we get that back into a nice soft piece of bread? No, we can't, because cool guys love their phones. Things are happening. We've got color changes happening, the texture's changing, all kinds of crazy stuff's happening with toast. We can't get that back, so that's not reversible. So toast is going to be a chemical change. Here we go. Okay, so once you're finished with this assignment, make sure you push saved up here at the top. You can exit out and turn it in. Y'all are amazing. Thank you.